An IP phone's journey from power on to being ready for calls is essential to understand. Let's break it down step by step. So imagine your Cisco phone as a computer waking up in the morning and getting ready for work. It goes through a series of steps to ensure it's properly dressed, knows where it's going, and has all the tools it needs to perform. This is like the boot up process, the journey from being powered on to being fully operational and ready to handle calls. The first step in setting up a Cisco IP phone is gathering the necessary information and configuring it in CUCM. This is the foundation of the IP phone's ability to register, communicate, and access network features. As an admin, understanding this process ensures efficient deployment, especially when networking with large numbers of devices. Let's go through the details of what you need to do to prepare and configure an IP phone in CUCM. So the first thing you'll do is gather the IP phone's MAC address. The MAC address is a unique identifier for each device on the network. So CUCM uses it to recognize and register the phone. Where you would find this MAC address could either be the packaging box, wherever it's like a printed label on the box that the phone came in. Bottom or the back of the phone, you look for a sticker with a string of characters, typically formatted in that hexadecimal format. Or you can just go into the settings of the menu settings of the phone and navigate, and you'll see the physical address. Now, that bulk administration tool simplifies adding multiple phones at once. So you upload a CSV file with all the necessary information, such as MAC address, extensions, and you can even use a template to have all these parameters. And this is really used for just, efficient configuration when you're deploying, phones at scale. So you would use the BAT tool, bulk administration tool. All right. So after you gather the MAC address, you know what the MAC is, you would create device pool be the next thing. Device pools in Call Manager allow you to group phones by location and departments to apply shared settings consistently. This ensures efficient management and reduces the need for repetitive configurations. So key settings in a device pool would be the date time group, which specifies the time zone and date time format for the phones. An example would be phones in New York and Los Angeles will have different date time groups. Call manager groups, which is a top-down list of up to 3 call manager nodes where phones can register. This ensures redundancy in the case that the primary node is unavailable. And then locations is a key setting which defines the maximum bandwidth allocated for calls over a WAN link. And this prevents oversubscription on slow WAN connections, ensuring that call quality. Regions is another key settings which set codec preferences between endpoints in different locations. An example would be to use G711 codec for local calls and G729 codec for inter-regional calls to conserve that bandwidth. Another factor is SRST, which stands for Survivable Remote Site Telephony. This provides a backup call control for remote sites using WAN during a WAN outages. So it basically just allows phones to continue functioning even when disconnected from call manager. And one of the last key settings I want to talk about is MRGL, Media Resource Group List, which just assigns access to media resources such as music on hold servers or conference bridges. Okay. Now, another thing you want to configure is phone security profiles. Phone security profiles is really just a collection of security related settings that you can assign to a group of phones. So these profiles just enforce certain settings like protocol. Are you going to use SIP or Skinny? The secure signaling, which uses that TLS, that transport layer security, to encrypt call signaling, and media encryption, so we can secure our real-time protocol for voice streams. Another thing, ensure you have your templates, like a phone button template, which allow you to predefine button layouts and features for a group of phones, which saves you time and ensures consistency across the board. So an example would be a default setting on a button may say maybe for a conference. But if your users don't frequently use the conference feature, you can reassign that button as a speed dial to provide a quick access to frequently called numbers that is in the system, right? So just a summary, number one, you are the administrator and you're going to get some things in order. And what you're going to get in order is you're going to gather the MAC address, right? If it's a bunch of phones, a bunch of MAC addresses, you're going to use the BAT tool, the bulk administrative tool, to add a bunch of phones or in the system. You're going to configure device pools. So you're going to apply shared settings like the date time group, call manager groups and regions, locations. You're going to apply that to groups of phones. Assign security profiles. Group, again, security settings for, that consistent enforcement. And you're going to utilize templates to simplify and speed up your configurations by predefining things such as button layouts and features. Now that we have everything set up on our end, the phone must now power on. And when it powers on, it will perform a quick self-check called power on self-test, a post. And if the phone is connected to a switch, it will use PoE, power over Ethernet, to draw power from that network. Now, you can also use for the phone a power brick or a power patch panel to give the phone power, but most likely it will be connected to a switch for simplicity, right? Now, PoE, power over Ethernet, is just a technology that allows devices like IP phones, cameras, and wireless access points to receive power and data over a single Ethernet cable. This eliminates that need for separate power adapters so you can simplify installations and reduce costs. Now, PoE have standards that define how much power can be delivered to devices. Break down some of the key ones here that you should know. We have 802.38F, which is basic PoE. It provides 15.4 watts. Watts is a unit of power. And this is really for low power devices. We also have 802.3AT, which is PoE plus. It's the second tier. It gives you about 25.5 watts. And this is for medium power devices, such as video phones. Then we have 802.3BT, which is the PoE plus plus, which is going to give you the max amount of power, 90 watts. And this is for high power devices like advanced conferencing systems. Okay, so power has phone. The phone has power now, but before an IP phone can communicate on the network, the switch is connected to needs to have a VLAN configured, voice VLAN to be exact. And a voice VLAN ensures that voice traffic is separated from data traffic, which improves quality, security, and manageability. So what you would first do is configure a VLAN. You would go into the switch and make sure you got VLAN, which you can name it voice VLAN in this example. You would assign that voice VLAN to a port, basically just specifying the VLAN that will carry voice traffic for the phone. So you would go into the interface, switch port, voice VLAN 10, or whatever the number is. You will also ensure that QoS, quality of service, is applied so you can prioritize voice traffic. So you would have a command such as MLS, QoS, trust, DHCP. You would check the port settings to confirm that voice VLAN is applied, which you can do a show running config, either to see all of the configurations running on the switch, or you can just specify show running config just for that interface. Some key notes to take into account is CDP or LLDP, which are both discovery protocols. You should enable them to help the switch identify the device as an IP phone and apply the correct voice VLAN automatically. So by setting up a voice VLAN, you ensure that the IP phone can obtain an IP address from DHCP and that voice communication is prioritized and reliable. Now from the switch, right up we have the router. The router plays a crucial role in helping the phone locate the DHCP server, especially in environments where the DHCP server is not directly connected to the same network as the phone, which is it in most cases. So the phone sends a DHCP discover message as a broadcast to the local network. This message essentially says, is there a DHCP server out there? Broadcast messages stay within the local subnet unless a router relays them. If the DHCP server is not in the same subnet, the router must forward the broadcast to the server using an IP helper address, or a relay agent, which you can call. This IP helper address tells the router where to send DHCP requests. So on the router, you would do such configurations. You'll go into the interface, apply the IP helper of that on that interface. And in this case, let's say the IP helper address is 192.168.1.1. And again, that's the IP address of the DHCP server in this example. All right, the DHCP server responds with an offer. The DHCP server receives the forwarded request and responds with a DHCP offer that includes the phone's IP address, subnet mask, default gateway, and other options like TFTP server option 150. Now, the phone will accept that offer. Now, the phone selects that offer, sends a DHCP request to confirm, and the server replies with a DHCP acknowledgement. Now, the phone has an IP address, gateway, subnet mask, default gateway, DNS server, and TFTP option 150. This DHCP option 150 tells the phone where to find the TFTP server for configuration files. So now, since it has that information, it will now communicate with the TFTP server. Now, it received the IP phone, has obtained an IP address from DHCP. Now it contacts the TFTP server to download the configuration files it needs to operate. These files contain essential details like firmware updates, device settings, and call manager group information required to register with CUCM. Now, some of the key components of this TFTP process, and TFTP is Trivial File Transfer Protocol, is one, configuration files. Each IP phone downloads this configuration file uniquely tied to its MAC address. The file name format is SEP, and then the MAC address .cnf.xml. So as an example, if the MAC address is in this hexadecimal format, A1, B2, C3, D4, you would see the phone request file shows as SEP001, and you have your MAC address. Now, what's inside this configuration file? So if a firm date update is needed, the phone will download and apply it from the TFTP server. It also includes shared settings for phones in the same locations, like the device pool configurations, date time group, Regis locations, that was in the device pool, and the call manager group. So it will have that up to 3 call manager nodes that the phone could register to. And the phone will attempt to register to the first node in the call manager group and fail over if needed. So just to summarize TFTP server process, it's really that critical component of this IP phone boot up process, because it provides the configuration files based on the phone's MAC address. It supplies the firmware updates when needed and delivers the device pool settings, including call manager group, which directs the phone to the call manager for registration. So now that we're done talking, the phone is done talking to the TFTP server, it goes to call manager so it can register to start making calls. The phone communicates with CUCM using SCCP, or Skinny Call Control Protocol, or SIP. session initiation protocol. And this depends on the phone's configuration, what we set up. Now, the phone will identify itself using its MAC address and request its phone-specific configuration. And then CUCM will assign the phone an extension and activate it for the use. So just as an analogy, it's like showing up at work, scanning your ID badge, and being assigned a desk and phone. Now the phone applies any assigned features, speed dial, soft keys, and other configuration settings. And now it's ready to make and receive phone calls. Now there will be some common problems with this process, such as phone doesn't power on, phone doesn't get an IP address, can't download the configuration file, phone even fails to register, or it does register, but some of the features are not working. There are some causes, some likely causes that you can check out and troubleshoot more effectively to figure out the issue. So if the phone doesn't power on, you know that maybe there's something with power adapter or no PoE. If the phone doesn't get an IP address, maybe you should look at DHCP and make sure option 150 is good. Something with the phone fails to register, maybe you should look at incorrect call manager configurations. Maybe some configurations are incorrect, or maybe there are some network issues. So just verifying this process and making sure that you have the MAC address, the connectivity, network connectivity is good. You have the option 150, DHCP scope is good. There's power, PoE from the switch. Then you will be able to resolve the issue more quickly and attack any problems. The IP phone boot up process isn't just a technical sequence, it's the foundation for a reliable collaboration network. Every step in this process depends on properly configured network services, protocols, and servers. So, by mastering this, you're not only just preparing for that CCNP exam, you're gaining the skills to troubleshoot real world voice networks effectively. I suggest you practice on some scenarios, such as scenario one: a phone powers on but fails to get an IP address. What steps would you take to troubleshoot? Or another scenario: a phone registers but cannot make outbound calls. What configurations would you check in call management? Some lab practices you can do is configure a DHCP server with option 150. And if you have the hardware, you can simulate a phone registration using SIP and analyze some call manager logs.